Alright folks, today we're going to be covering centers of data and weighted averages. So make sure you have your class examples worksheet handy as well as a calculator. First of all, let's go ahead and talk about a couple of definitions that will help us today. When I say measures of center, I'm looking at some statistics that lie in the center of data or give us those types of information, and those are mean and median. If you've worked with these before, they should be very common to you. Mean is your average value, add up everything in the set, and then divide by the number in the set. Median is calculated by ordering your numbers and then finding the middle value. Mode is on here because it's another common measurement, but it is not a measure of center because mode, the number that appears most often, doesn't necessarily have to fall in the middle of the set. Okay, so it is not a measurement of center. Other things we'll need to talk about this lesson are frequency and relative frequency, and you may have heard of these before or used them a little bit. I just want to reiterate, frequency is the number of times something occurs. It's a count of how many. And then relative frequency, the word relative just means we have to relate it to something. So we take that frequency and just divide it by the total count. Okay, so this can be represented as a fraction reduced, as a decimal, or as a percent. Okay, a lot of times I'll use it as the decimal if it looks nice, and then if it doesn't, I'll go back to the fraction. So let's go ahead and get started with an example here. This is actually a frequency table. In general, usually your frequency tables are switched. Usually you've got some categories here. In this case, it's talking about the weights of a team on a weights of members on a wrestling team at this high school. And a lot of times, usually they list the categories first, and then they give the count of how many show up in those categories. So here, you've got 4 members who weigh 120, 3 members who weigh 135, and so on. Okay, so our first question is just, based on this table, can we tell how many members the team has? Well, hopefully, you see members is here. You just got to add those up. Okay, so take your 4, 3, 3, 2, 1, 1, and we come up with 14 total members. Make sure you're always labeling anything that needs it. Now, our job on Part B is to find the mean weight. Now, I said that we were talking about weighted averages. Okay, so a weighted average just means that each of our different categories have different number of members in them, or they count for more. If you see in our table here, this 120 weight counts for more than this 285 weight because there's more people who weigh that much. So we can't just add up these values and divide by the 1, 2, 3, 4, 5, 6 different weight classes. We want to make sure that we're counting every single person here. So one way to do that is literally take 120 plus 120 plus 120 plus 120, or we can just say that's multiplied by 4. So a lot of times weighted averages, we just multiply by the weight. Okay, so that would look like 120 gets weighted by 4, and then the 135 gets weighted by 3, the 145 gets weighted by 3, 170 counts for 2, and then the other guys only count for 1. Now, I am going to say times 1 here only because it kind of helps us with weighted averages in general on what we divide by. So, in general, when we're talking about an average or a mean, we always add them up and divide by the total count. Well, we decided our total count was 14, but that comes from adding all of these weighted values together. So that's kind of a way you can set this up always so that you're dividing by the right total value. Okay, so go ahead, type that in for me. Okay, pause while you get that taken care of, and then we'll come back with the answer here. So that comes out to 152.5 pounds. Now we do have to keep in mind when we're talking about this, with the wrestling team, just because they're wrestling at the 120 weight class doesn't mean they actually weigh 120. They could be weighing 110 or 115 as long as it's less than or equal to that. So this average weight is not talking about the average weight of someone on the team. It's really talking about the average weight class, which again, in this situation, doesn't really happen because there is no such thing as a 152.5-pound weight class. So keep that in mind when you're finding averages. Do they actually make sense for your context there? The next thing we're going to do is calculate the median weight. Okay, remember for median, you have to make sure your numbers are in order. They are for us. Now, we don't have to list these all out to find the median. Okay, what I always do for median is figure out where it's going to show up first. Okay, so here's what I mean by that. We know the median is the middle. So what you can do is always take your number in your set, that's 14 for us, and just split it in half. Okay, so that means there's going to be 7 in the front half and 7 on the back half. Well, if we split that in half, that means our median actually falls directly in the middle of those two things. So what we're going to do is go find 7 on top, 7 on bottom, and we'll split the difference. These are already in order for us, so we just have to count 7. There's 4, there's 7 total. Then you'll notice on the other half, 1, 2, 3, 4, 5, 6, 7. Our median falls right in the middle of those two things, so we have to just take the average of these two things. So 135, this one's obvious to see, but some of them aren't. So when you're finding the average, you just add them and divide by 2, since there's two numbers here. And we're going to end up at 140 pounds for our median. Again, there's no weight class that actually is 140, but it kind of gives us an idea of where the middle falls for that. Okay. I'm going to take this time now to show you another way to do this. For a chart like this, when there's not very many numbers, it's really simple for us to find the mean and the median, mostly because, especially for the median, our data is organized, so it's pretty straightforward to do that. Sometimes it's not, so I'm going to show you how you can do this on your calculator as well. So, in order to put this information into our calculator, what you need to do is find the stat button. We're finding statistics, it makes sense. Okay, so that's right here. Okay, find that on your calculator, go ahead and hit that. And what this allows us to do is we can edit list. We can put all of this information in a list for it. So we're going to go ahead and hit enter because this one is already selected. And then what we're going to do is make sure that all of our information is in there. Now, if for some reason, and I'm going to show you over here so I don't have to retype something, if for some reason there's some data in your list already, what you're going to do is go up to the very top. So you're doing this on list 1 if you see any information in there. Okay, you're going to go up to the top, hit clear, and then enter, and that'll get rid of everything that's in there so you can type in the new stuff. If you accidentally, let me do this real quick, if you accidentally hit delete, notice that went away, and that's a problem. Okay, but you can fix that really quickly if you hit stat and then setup editor. That brings that list right back. Notice I just hit enter and it made it done. If you go back into stat, my list 2 is there again. Okay, so if you accidentally delete something, not a big deal, just get it back with that setup editor. But what you need to do for this one, I said we could take this times 4 and that's a lot quicker. With the list, you have to type them all separately. So make sure you hit 120 4 times, 135 3 times, and so on. Okay? At the very end, when you're done entering your data, you'll notice that the last one blank is 15 here, meaning this is your 14th. Make sure that matches the number that was supposed to be in your set, and you'll be okay. From there, double check your numbers, always, always, always. But from there, we can do stat, and then calculate. If you hit the right arrow here, this first option is one variable statistics. We're only talking about one thing, and that's weight. So if we click on that, it will calculate our statistics for us, not only mean and median, but some other stuff as well. Okay, so you may see this screen, you may not. Either way, hit enter until something pops up. And here, the first thing, the mean is represented by this X bar. That 152.5 is what we got for our mean. If you scroll down, you'll see the median is 140. Okay, we're going to use this next class a lot to find these other things that are in here. So we'll talk about those more in detail next class. Let's go ahead and move on with the next part here. We wanted to find which number, the mean or the median, best describes the typical weight of a member on a team. Why? So if we look at our numbers, let me just remind you, the mean was 152.5 and the median was 140. If we want to find out the typical weight for a member on the team, we need to think about where are more people? At what weight class do more people fall? Okay, well hopefully you see that most of the team is right there. Now some of the team obviously is a little bit higher, but the majority is at the lower weight classes, so the lower guy works for us. Now the reason why is really because of this value right here. Check out the difference between these weight classes versus this last one jumps from 190 to 285. Okay, this is what's known as an outlier, and we're going to get more detailed about that down the road as well. Okay, but any number that's significantly higher than the rest or significantly lower than the rest is going to skew the mean. It's going to affect it heavily. And that's not really good if it's trying to give us a typical value for, in this case, the weight of the team. So we're going to say that the median is better. And the reason why is because the mean is affected by that 285-pound member. So mean is really affected by extreme values, where the median really isn't. The median doesn't care what these weights actually are. They care that they're in order and they find the middle. So a lot of times median is actually a better measurement of center than the mean is, even though the mean is more commonly used. Alright, we're going to do a couple other things, and this is not on your paper, but what I want you to do is just add to your table up top. Okay, so extend this. Doesn't have to look pretty, but I just want to make sure we're really clear on what frequency means and what relative frequency means. Oops, let me redraw that one. Okay, so go ahead and just add frequency and relative frequency. So the frequency, remember, by definition is the count of how many. Okay, well that's actually already taken care of. The count of how many, I told you this was a frequency table. Okay, it's the 4, the 3, the 3, the 2, the 1, and the 1. And a lot of times frequency tables are just labeled as frequency, but we want to make sure we always label it as what it's talking about. Here, it's talking about 4 people, 4 members on the team. So we're going to, in parentheses, just say this is talking about members. Okay? But that kind of builds us up for the relative frequency. So the relative frequency, remember, is the ratio of frequency over our total. Our total number of members was 14. So I told you that frequency could be determined as either a fraction, a decimal, or a percent. And in general, I like decimals better. Unless they're not very nice, then I'll go to reduced fractions. So if we think about this one, it would look like 4 over 14, which we would reduce. Or, again, like I said, if it looks nice, I want to use a decimal. In this case, go ahead and type it in, and you'll see this is not a nice decimal. This is not something we want to write as a decimal necessarily, unless we have to graph it a fraction is better in my opinion here. So let's go ahead and reduce this. This looks like 2 over 7. Relative frequency is done there. The next one is 3 over 14. Already reduced, we're good to go there. Next one, 3 over 14 again. And then we've got 2 over 14, which is 1 over 7. 1 over 14, reduced already. 1 over 14, reduced already. Now, what's really important to note here, frequency is always going to add up to the total. Our total was 14. So that table always has to add up to the sum there. And then here, this column always has to add up to 1, because we're thinking about this as 100% of all of our data. Okay, so that takes care of that. Just give you a little bit of help on your homework. The next thing we're going to talk about is sigma notation. And you've seen this before, hopefully, in Algebra 2. This symbol here is the capital sigma, and it stands for summation. So anytime you're adding stuff, they'll use this symbol to kind of condense a sum to make it look nicer when you've got a large set of data. So I want to talk about the pieces in this sum just as an example to kind of give you an idea of how these are read. So they're always going to have this index I. This letter can change. It could be N, it could be J. Really, they can choose whatever letter they want here. Okay, but this is the index. And they're going to say the index starts somewhere. And so the bottom is the starting point. It's saying that I'm going to start at the first term in my set. And then up here, they just have a number, and that's the ending value. So this tells you just term. So x sub I means I'm starting at 1, x sub 1, I'm starting at the first term. And then I'm going to end at x sub 10, or the 10th term. Okay, so this is just a fancy way to write the term number. So if x sub 2 means the second term, and we're never going to say x sub 2, we're just going to say that's the second term. X sub 4 is going to be the fourth term, and so on. Sometimes right here, this, instead of looking like a term with subscript, it will have an expression that is a formula, but for today we're just going to have this notation with the x sub I. So let's apply it to these examples here. Okay, before we even get to some actual math, I just want to quickly go through each of these and talk about what they mean. So here, this means the sum of the first through the third. So I take the first plus the second plus the third. This sum means I'm going the second through the fifth. So I take second, third, fourth, and fifth and add those together. This is the first through the fifth. I'm adding 1, 2, 3, 4, 5, but then I have to multiply it when it's smushed by 1/5. And then here I've got a couple sums that I'll end up subtracting. Okay? Well, in order to do this, we have to know what these terms represent, and that's given to us here. It gives us all of the values, first through fifth, what they mean. So, first up, this one, remember, was first through third. We're going to take first, second, third, and add them together. So that looks like 5 plus 12 plus a negative 3. If you just recognize this as a minus 3, go for it. When you add a negative, you just subtract. Okay, we're putting those all together to get 14, and we're done. It's not difficult once you know what it means, okay, because really it's just simple addition. You just have to plug in the correct values. Well, the correct values for this next one is 2 to 5. Okay, so I'm starting at the second term, which is 12. And then I'm adding the negative 3, the third term, adding the fourth term, which is 0, adding the fifth term, which is 10. Putting those all together, I get 19. Alright, anytime you've got something out front, what I want you to do is just leave it out front and take care of the sum. We'll take care of that multiplication at the very end. Okay, so what I want you to do is go write your 5 terms that represent that sum. Pause the video and do that for me, please. They are 5 plus 12 plus negative 3 plus 0 and plus 10. All right, we're going to simplify inside those parentheses first. 1/5 times 24. And that's really 24 divided by 5, which you can leave like that because it doesn't reduce, or you can write it as a decimal, 4.8. I'm good with either. All right, now what I want to talk about really quickly is kind of shortcuts with these. If you're using the same set of numbers, sometimes you can easily figure out these numbers faster, or these sums. So if you check out number 3, it went from 2 to 5. Well, the only thing missing there is the first term. I could have calculated this sum a lot faster by taking 19 plus 5. Why? Because this right here was already taken care of up above. So anytime you're dealing with sums that you have a lot of problems dealing with the same given terms, see if you can shortcut that way. Now I said that because we have a difference right here of two sums, and we've already found those. I know that the sum from 2 to 5 is 19 because I found that up above. I know that the sum from 1 to 5 is 24 because I found that over here. So all I have to do is take 19 minus 24 to get the final answer here of -5. Sums can be negative, okay, because sometimes we add up negative numbers, or in this case, we subtract sums where the larger one was second, okay? Let's look at another example. This is more on interpreting how these summations are used. So it says a family-friendly beach resort has a total of 32 family suites. Okay, you'll notice in this sum it's got 32 on top. All right. Now it says let G sub I be the number of guests who check into each suite. Okay, so before we put this together, I want to think about this. G1, G2, G3, because remember this I is just a placeholder for some number that you're going to plug in. Okay, so if this is going to be the number of guests who checked into each suite, this would be the number who checked into the first suite, this would be the number who checked into the second suite, and so on. So then, what would this mean? Okay, remember first we're going to talk about where it starts, where it ends. This takes the first term, adds all the way up to the 32nd term. So it takes G1 plus G2 plus G3 plus G4 and so on. And I'm just going to write that. All the way to the last one, which we said was 32. We want to know, what does this represent? Well, again, if G1 was the number in the first suite and this was the number in the second suite, and we add all of those together, we would get all of the guests in all of the suites. Okay, so now it wants us to use sigma notation to express the mean number of guests per room. Okay, so anytime we're doing a mean, we take the total value. So this is number of guests per room. Okay, so that means guests goes on top, rooms go on bottom. So total guests over per room means total rooms. Okay, well here's the thing, folks. We already found sigma notation for total guests. That was that right there. So this sigma notation where it starts at the first suite, ends at the 32nd, and they use G sub I, G for guest. I don't care if you use X, okay? So those guests are the total. We just have to divide by the number of rooms. Well, we had 32 suites, so we've got 32 rooms here. Now, in general, dividing by 32 is written as times by 1 over 32 because this looks kind of messy. It's nicer to write it with this 1 over 32 out front. Okay, so when you're given a sum, you will see it like this way more than you see it over here. I don't personally care which one you use, but you will see that second one more often. Okay, so it's good to recognize that as the mean. Alright, go ahead and flip that over. We're going to do some weighted average stuff and some frequency really quick. Great. A big application of weighted averages is with grades. Okay, so it says a college economics course, homework counts for 25%. I'm going to go ahead and put that in the table here. Then it says quizzes are 10%, tests are 45%, and attendance is 20%. Frances and her friend Adam earned the following scores during the semester. Who received the overall higher course grade? Okay, so remember, a weighted averages adds up all the things, but it always multiplies by their respective weights. Now, one benefit of using percentages is we can actually save ourselves some work. So let me show you a couple ways in how this works. First with Frances. Okay, now we talked about what we're going to do is multiply the grade by the weight plus the grade by the weight. Okay, so let's get that done. So Frances had the grade of 89 and it was weighted at 25%. The next one, quizzes were 82 and it was weighted at 10%. And then the next one is tests were 87, it was weighted at 45. And then we had attendance grade was 100 and it was weighted at 20. Well, I told you there was a benefit to percents because guess what these add up to? We don't have to take this and divide it by 100 if we just change this to a decimal. Now you're welcome to do it either way, because if we change it to a decimal, we're dividing by 1. 100% is 1 as a decimal, and we don't really have to do that. So you can save yourself that hurt. But I did want to show you that it does work the same way as us calculating that mean on the front side. Okay? Go ahead and type that in for me, and let's see what Frances ends as a grade. Pause the video while you type that in. Okay, she got an 89.6. We're going to do the same thing for Adam to compare his score. Okay, I want you to set this one up. Pause the video and get me that grade. We've got the same numbers here, but instead we're going to look at 95 times 0.25. We're going to look at 90 times 0.1. We're going to look at 92 times 0.45, and attendance last 70 at 0.2, and that gives Adam an 88.15. Okay, that means that Frances, okay, even though Adam has some higher scores through here, his attendance kind of hurt him at that 20% value. Okay, so Frances won this one. Okay, anytime I'm asking you for these types of problems comparing, you got to show your work to show me each score, and then you can tell me who did better. All right. Next up, it says in a college calculus course, suppose homework counts for 25. I'm going to go ahead and write this out so we have this organized information. Sorry, my pen died there. So homework is 25, and then it says 3 exams are 17.5 each, and then it says the final is 22.5. Great. So if a student has an average of 95 on the homework, an average of 84 for the 3-unit exams, could the student end with an A in a class? We're going to assume 90, 80, 70, since this is a college course. That's pretty standard. And then it says, if so, what would they need on the final? Okay, notice the final is missing here. So this is not calculating the weighted grade. It's calculating, well, what score would I need on the final to get this weighted grade? So the first thing we're going to do is set up how this would look weighted. Okay, so we want to know the grade for homework and multiply it by the 0.25. Our grade for homework, it said, was 95%. I'm just going to leave it as 95 because we want to know the grade. Okay, so I'm not going to write it as a percent there. Then we've got our 3 exams. Now here's something you have to pay attention to. If you just add these 25, 17.5, and 22.5, that doesn't add up to 100%. But that's because there were 3 of these. Okay, so you can multiply this 3 right away, or you can put it out front. It does not matter. As long as at some point you are multiplying by 3, okay, you're good to go here. So there's 0.175. Again, you can write that times 3 right away if you prefer. Okay, but the exams, it says, was an average of 84, so I'm going to tuck that in there. And then it says we don't know what the final was, but the final we do know is weighted at 22.5, so move your decimal twice, 0.225, and we don't know what this is. So I'm just going to put an X there. And our goal is to figure out what's going to give them an A. So an A would look like 90 or above. So I'm going to write greater than or equal, we need this to be greater than or equal to 90. Okay? This is another benefit of using decimals instead of division. If we divided this all by 100, we'd have to multiply that over first. We saved a step by not doing that. Alright, so what we're going to do is kind of solve for x here. Okay, so the first thing we need to do is get rid of these guys. If you want to add those together first, you certainly can. So that would look like 95 times 0.25 plus 3 times 84 times 0.175. And let's get what that looks like, 67.85. And this, I'm going to switch around so it looks less funny, 0.225x greater than or equal to 90. You're solving this like it was an equal sign, but that greater than or equal is going to be important, so I'm going to leave it there. Next thing, we have to subtract that over. So 90 minus that guy, 22.15. And last step is just divide that by our 0.225. And we get x has to be greater than or equal to 98.4 repeating. So, is it possible to get an A? Yes, because that is possible. Okay, you can get greater than a 98.4. Now, if that said greater than 120, that's not possible for a final unless there's some crazy extra credit happening. Okay, so is it possible? Yes. What would they need on the final? Well, they'd need at least a 98.4. I would say they would need a 99 or above because all these other scores are rounded to the whole number. Alright, so that gives you an idea of how you can solve for missing pieces. You will have problems like that on your homework, so if you struggle at all, please reach out to me. Alright, we're going to do something with weighted averages and frequencies. Okay, so this one, it's got a clothing store advertised the first 200 customers would receive free gift cards, 5, 15, 50, or 100, and it lays out how many of each there would be. Okay, it says there's 5 100, 10 $50 cards, 35 $15 ones, and the rest are going to be $5. So let's figure out the rest first. Okay, there's 200 total, and 5 are here, 10 are here, 35 are here, so that's 50 of them. The rest has to be 150 then. Okay, so that's first up. Now, what we want to do is calculate the total value of all the gift cards. This is like a weighted sum. So we had 5 100s, that's worth 500, but we can represent it by this product. Then we've got 10 at 50. Then we've got 35 at $15. And the rest we said was 150 at $5. Type that in for me. We've got $2,275 total. Okay. Now we're going to lay this out in a table because tables are good for organized information. Okay, so we've got card value and the frequency. Okay, set up a table just like this. Label your top. Card value has to be in dollars. Frequency is talking about how many cards. Okay, so make sure those labels are there. Otherwise, we have to label every piece, and it's not as fun. Okay, so we had 5, we had 15, 50, and 100. And then again, we're laying out those same numbers. Notice I put these in order. Okay, a lot of times it's better to organize them by lowest to highest or highest to lowest, whatever. But that way this is organized. There were 150 of those guys, 35 of the 15, 10 of the 50, and only 5 of the 100. It does say calculate the weighted average, okay? The weighted average we don't have to work hard for because we've already got the weighted total. The weighted total from the last part A was 2,275. We just got to divide that by the total number of cards, which we don't even have to add up. It was told to us was 200. Okay, type that in for me. Now, when you get this, 11.375, okay, this is talking about the average value per card. We're going to round it to what makes sense then, which is about $11.38. This is another situation where the average value doesn't really mean a whole lot in terms of this isn't actually happening. You're going to go in and get either a $5 card, a $50 card. You're not going to get one that's worth 11.38. Instead, this is what the company, this clothing store, is spending per person of these 200 people. Okay? Now with this, what we're going to do is create a frequency table. Okay, those card values are the same. Again, let's tack a dollar sign on. 5, 15, 50, 100. And we're going to do relative frequency. What I want you to do is just type these in your calculator. We already have the frequency up above, and all we're going to do is divide it by the total. Okay, and I'm going to write them as decimals because in this case they do come out nicely. Okay, so first up, we had 150 from your frequency, but we want to divide it by the total 200. Comes out nice, 0.75. Okay, doing the same thing with the next one. We had 35, so we're going to divide that by 200. That's 0.175. The next one, 50 over 200, sorry, not 50, 10. Make sure you're dividing the frequency. That's 0.05. And last one, we only had 5 at the 100, and that's 0.025. Now, the reason I'm recommending decimals is because this one we're making a graph for, and it's way easier to plot decimals than it is fractions. A lot of times when the fractions don't have the same denominator after you reduce. Okay, so let's talk about what this is going to look like. We're always going to put our categories on the bottom. Okay, so our categories here are the different card values. Alright, and we're split up into groups. So what we're going to do is split this x-axis into 4 groups. I want to spread them out as much as possible. I don't want to do 1, 2, 3, 4 and then not use the rest of my graph. I want to spread them out. So we're going to use a few chunks for each here. I'm going to say from here to here, let's be our 5. And then 3 more. This bar will be our 15. And this bar will be our 50. And our last bar will be our 100. Okay, I'm saying bar because we're making a bar graph. okay? Separating our categories into chunks. A lot of times bar graphs have spaces in between, but they don't necessarily have to. Okay, then our relative frequency, our highest value is 0.75. In general, relative frequency, remember, adds up to 1, but the individual pieces don't have to. Okay, so we need to go to at least 0.75. Okay, it looks like counting by tenths will be good here. 0.1, 0.2, 0.3. And you don't have to label every single one. If you want to label 0.2, 0.4, 0.6, so it's a little bit more spread out, feel free to. And I don't really have to go past 0.8 because that is my highest value. Over here, this is relative frequency. Does not have a label. That's important, unless you're writing it as a percent. And let's go ahead and fill in the heights here. The first one's supposed to be 5 going to 0.75, so halfway here. Just draw a little line and then shade it lightly. I just do these little dashes across. You don't have to work too hard there. The next one is 0.175, so not quite to 0.2. Draw your little line, shade it in. The next one is 0.05, that's halfway to 0.1. And the last one, 0.025, that's a quarter of the way, so half of that last one. It's pretty small, just make sure it looks close. Okay, so again, don't spend a lot of time shading these in, but you might outline them so that I can tell the difference between them. And the last details that we need on a graph are a table, heading, title, sorry, and a table source. So what we want to do on top is talk about what this gives information on. We're going to always start frequency graphs with distribution. Because the word distribution, and we'll talk about this a little bit more next class, but the word distribution is anything that displays frequency. Okay, so distribution of, and then we'll talk about the two things it's measuring. Well, it's measuring the relative frequency of our different card values. So distribution of relative frequencies. And you can abbreviate here. Make sure you are capitalizing though, because titles are capitalized. So these are talking about our cards again. I'm going to call them gift cards. So relative frequency for gift card, and it's specifically at a clothing store. I think I gave you a little bit more room to be able to write this. So just kind of like our sentences, we want to make sure we include the important information, the intersection, so our headings here, but also give details about what it's talking about, okay? Last thing is if there's a source, we want to put one, okay? Just like with our tables, we'll put it at the bottom. Even if you don't have a source, you're going to write source here, and then you'll just list unknown. So hours, it says that the new store manager put this in a store memo. So we can say that this is an internal memo as the source, or if you want to say unknown because it's not really specific on where this came from, that's okay. I'm going to just put this internal memo. Alright, last couple of things here, and this is really to help you with your homework. It says compute the weighted average using relative frequency values and compare the results. So we found the weighted average last time by taking 5 times 100 plus 10 times 50 plus 35 times 15 plus 150 over 5, and then we divided it by 200. This is what happened in Part B. We took the sum from Part A and we divided by 200. Well, what we're going to do is just use relative frequency, and this is actually what we did in numbers 7 and number 8 on the weighted averages for those courses, is we can actually write this as a decimal instead. This 100, sorry, let me use the right value. This 5 over 200 is this guy. This 10 over 200 is this guy. This 15 over 200 is the next one, and so on. Okay, so, or sorry, this 35. These are the relative frequencies. So one way to calculate the weighted average is multiply by the weight and divide by the total. Another is just multiply by the relative frequency. Use those decimals instead. So I can take the card value 5 times the 0.75. I can take the card value 15 and multiply it by 0.175, and then keep going through the chart there. And that's going to give me the exact same thing as we got above. I want you to type that in so you're sure that this works. Okay, so two different ways. It's not to say that this way is better, because honestly for this particular example, I'd rather calculate it the way we did it in Part B. However, if I'm given percentages like we had in number 7 and number 8, I'd absolutely rather use the relative frequency, those decimals, instead of calculating the weight the normal way. Okay, so use that to your advantage. Now, last question says, well, what if there were an equal number of each gift card? What would the average be? Just like on the front side when we had all of those different weights, I said we can't just add up the weight classes and divide them by 6 classes. That wouldn't give it, because there are more members weighing 120 than there were the 285. We can't just take all of these and divide by 4, because there's different numbers of each card. But we're asking on E, well, what if they were the same? Well, if they were the same, we could do that. 5 plus 15 plus 50 plus 100, and then divide that by 4. Go ahead and type that in. That gives us $42.50 per card, or per person. But the difference here is that would mean if we're splitting 200 cards equally, this one's got 50, this one's got 50, this one's got 50, and this one's got 50. If you're having 50 cards that are worth $100, there's a lot more money that you are paying out, and that's why this average is so much higher. Okay, so weight matters, and that's the whole idea of this lesson. Okay, if you do have any questions on your homework, please reach out to me for help.